Now this illustration deals with rating or setting of the overcurrent protection device when the system now is over 1,000 volts. We've been reviewing overcurrent protection for systems 1,000 volts or less. Now, kind of coming out the gate, let's kind of understand this if you haven't had time to really study the 2020 NEC with some of the major changes. But notice we have a new Article 311. And that new Article 311 deals with systems over 1,000 volts, medium voltage, high voltage. And all the information for tables to size conductors for a system over 1,000 volts have been removed, have been moved and relocated in this new Article 311, along with Article 328 for medium voltage. So when you see these new tables, instead of them being table 310 so-and-so, it'll be table 311 and so-and-so. Now, notice now with the information that's above in the illustration, we have a feeder overcurrent device using CBs, and we know if a transformer is involved, then we know 450.3a will reference 240.4 and 240.21 for systems of 1,000 volts or less. But if you're over 1,000 volts with your electrical system, then 450.3a would send the user where transformers were involved to 240.100 and 240.101, depending on, are we using circuit breakers, fuses, relay systems? What are we using for protection? And then notice that we're just dealing with conductor sizing here and setting of the overcurrent device. But each individual component that you see in that illustration, that's not conductors and conduits, say, we would reference Article 490 to jerk out our requirements for certain components over 1,000 volts. So with that information, let's move to step 1 in the boxed in information, and notice table 311.60C, as in car 74, lists a 3-aught conductor in a raceway system as you see there. A 3-aught's good for 200 amps. And then you notice in the illustration itself, it's illustrated that we have 3-aughts AWG aluminum conductors, table 311.60C as in car 74. Now, step 2, notice if we need to, 240.101A would allow 600% sizing. So 600% of 200 amps would be 1,200 amp that you could set that protective device to allow equipment to operate that needed that sizing. If it was a transformer, then you could go to table 450.3a and get the same setting that would protect the transformer and the windings of the transformer, but not the conductors. You got to come back over to 240.100 and 240.101a to do that. Now, step 3, say that you were using and calculating with fuses, where you were selecting a fuse system, then you would go to 490.21B as in boy, and you would get your arrangement of what would have to be provided using fuses, but you could go to 300%, which would be 600. And notice the difference. 600% for circuit breaker settings, but only 300% for fuses. Now, that's the same for transformer protection. So it kind of goes together to allow the same percentages. So that's what this figure 9-46A is illustrating when we want to use circuit breakers or fuses. In this case, for a feeder. And you notice to the left in the service equipment, circuit breaker type equipment, arranged and installed by 490.21A. But to the right, we have fuses, and the fuse system would be installed and selected in accordance with 490.21B. So this illustration here is just simply illustrating those percentages based upon using a circuit breaker or fuse protective system.